So as I was mentioning earlier, if you're just now joining us, Dragon is now just 220 meters in front of the space station. The astronauts aboard, Bob Behnken and Doug Hurley, have commanded a manual hold. That's to perform a manual piloting test. There is a very nice shot of the Dragon vehicle from cameras aboard the space station. You just saw one of the Draco thrusters there firing, just to keep it in that hold attitude, flying right in front of the station.
Yeah, we have two cameras on the very forward port of Node 2, so right where Dragon's going to be headed following the completion of this manual piloting test.
Dragon SpaceX on Big Loop. C2V2 link reconfiguration is complete. The soft capture ring extension is also complete.
Dragon copies on the Big Loop. Good ring extension and C2V2 reconfig.
So those comms on the Big Loop, the core, the crew operations and resources engineer here at SpaceX letting the crew know that we have a good TDRS link again. Good C2V2 link again. It's common communications for visiting vehicles. And we actually heard a little bit earlier as well comms to Chris Cassidy to monitor this manual piloting test.
Dragon SpaceX on Big Loop, you are go to execute the proximity manual flight test per procedure 4.041, and I have the target fuel levels when you are ready to copy.
Copy, we're go for 4.041, and we're ready to copy the fuel constraints.
Your 1/3 fuel usage will be 60.9, 2/3 58.9, and terminate 57.9.
Okay, we copy 60.9, 58.9, and 57.9. We'll pick up in 4.041.
Good copy, and we're with you.
All right, so they're going to start maneuvering Dragon again, making some translational maneuvers. We did get some insight that it looks like they're a little bit to the left of the docking axis right now, and so we should expect them to move directly into the center line as one of their first maneuvers. That's going to be their very first maneuver. And then they have a strict list of choreographed steps just to test out moving on the other axes. And we heard the core Anna Menon calling up the expected fuel usage inside Dragon. They're going to be keeping a close eye on that just to make sure they're not overusing the propellant in this flight test, making sure we still have good margins for all of the approach maneuvers, and then obviously for everything at the end of the mission itself.
Yeah, and the thrusters that we're using here.
Dragon, on the Big Loop, we are commencing with docking axis capture.
We are following along with you.
So the thrusters that we expect to see firing here would be on the service section or on the trunk. And you'll see some plumes coming out from the shot on your screen.
first part of this maneuver, is just to really line them up perfectly with that docking axis. So they were already several meters off once this hold occurred, and so they're making very low impulse commands being sent to those Draco thrusters. Again, as Shiva was saying, there's the 12 around the lower part of the Dragon capsule that they're going to be using. We're seeing small bursts now.
Yeah, and they actually have a couple of precision modes where they can put in sort of coarse and fine inputs into the vehicle. That's all stuff that they can control off of those touchscreen displays to get the right amount of impulsive thrust into the vehicle. If you're trying to get a little bit oriented to how the vehicle is positioned, that's the nose cone on the top of your screen. So Bob and Doug would be sitting sort of underneath that nose cone and see the pressurized portion of the capsule, and their seats look up into the displays and also would look towards the side hatch, which is currently sealed underneath on the opposite side of where that nose cone is. Very cool to see those thruster plumes.
Yeah, the Kronos emission control Houston actually opened up the iris a little bit on that camera on the space station so we could see these plumes.
And SpaceX Dragon, we've completed the docking axis capture maneuver. We're going to move on to the YZ translation.
Copy, we're with you.
All right, sounds like they've got themselves lined up exactly on the docking axis, so directly in front of that international docking adapter on node 2. Now they're going to begin some lateral and axial maneuvers. So again, just putting Dragon now off the docking axis, and to just continue these translational maneuvers. So at this point, we should see them head up to the right and up from this view, as they're just making very small adjustments in the Dragon's positioning in front of the space station right now.
And here comes the translation.
We copy.
Yeah, in the data, it looks like we're seeing the 6 thrusters essentially on the bottom of the spacecraft right now from this view, lighting up. So it's going to begin to move them straight up. And it's difficult to tell, but there is a very slow drift upward right now.
Yeah, it looks like they're going about 0.1 meters a second, if I'm looking at this data correctly. So very slow and steady. And they will probably do a quick correction to stop that upward movement. It's a little surreal seeing Dragon so close to the space station. Less than 18 hours ago, I was on the pad at Launch Complex 39A. Now it's so close to its destination.
And being piloted by humans for the second time already in this mission.
Man, I would just be too excited. I don't know how Bob and Doug keep this so professional.
It's that test pilot mentality.
Yeah, they both have thousands of hours in aircraft. Both test pilots.
Yeah, both came from military test pilot backgrounds. Bob Bankin, the Air Force. Doug Hurley, a Marine Corps aviator.
And then I believe a Naval Test Pilot School, so... A little bit overexposed there, but you can still see the thrusters firing.
Yeah, our Kronos working to do that deliberately for us so we can see those thruster plumes from this camera view. We're at a normal exposure, so not able to see those jets into the darkness of space. But when we do overexpose a little bit, you're able to see those thruster plumes coming out of the Dragon spacecraft.
Yeah, it's amazing how the plume has to catch the light just the right way for us to even see that it's happening outside of data. Yeah, and looking at the data now, it looks like we have zeroed out that radial velocity delta. So Bob and Doug cleared out that small translation test that they did. We may get a radio call down here that they've completed the Y direction testing. Now, I know we've mentioned this a few times, but it looks like the spacecraft are totally still right now. And that's partially true. They're still relative to each other. But right now, both the space station and Dragon are going around the world, what is it, about once every 90-ish minutes?
Yep.
Or less?
Once every 90 minutes, seeing 16 sunrises and sunsets every single day. And while our view right now...
We've completed the Z translation, moving on to the Y.
We copy. We're with you.
I copy. So I was a little bit mistaken. They just finished up the Z direction, doing the Y next.
Dragon, SpaceX on Big Loop, you have used approximately 1/3 of your prop test budget.
And Dragon copies 1/3 of the prop test budget.
So the Corps letting the crew know how much prop they've worked through. Still have 2/3 of their budget left to do test maneuvers. And of course, any bit of propellant that they're using is just a little bit less margin if they needed to use it for something else. but a good way to exercise the system, see that manual piloting works as intended, and I'm sure for them to have a chance to provide some feedback on how manual piloting actually felt in space and how the control felt.
Yeah, a big part of their job for this mission is really to not only put the vehicle through its paces, but to take a lot of detailed notes and mental notes that they're going to be passing along to any future crew members flying on board Crew Dragon. As we've talked about, the simulators have been a pretty good guide for how the actual manual piloting goes, but things like the ascent up to orbit were quite a bit different from what they expected. And so they're just taking all of that in, internalizing it, and a big part of their job once they come home is to pass that along to all of our upcoming crews, one of which is targeted to launch just about a month after they come home. That Crew 1, the outfit of 3 NASA astronauts, Victor Glover, Mike Hopkins, and Shannon Walker, and a Japanese astronaut, Soichi Noguchi, will be aiming to do that flight a little bit later this year. So going through the paces right now, looking at our data, I think I made the same mistake you did, where I assumed them going up would be the y-axis. It looks like that was actually their z-axis, and the y now them moving to the right. So we're seeing some small shifts. They're continuing to use up a little bit of their prompt budget. We heard they're already a little past 1/3.
Yeah, it's actually something interesting about both aircraft and rockets. When you consider the coordinate system, what we refer to as the x-axis is usually the one that goes through the nose. So in the case of Falcon 9 and Dragon sitting on top of each other, the x-axis would have been pointing through the nose cone going up. Can be a little bit counterintuitive. And then actually in aircraft, the z-axis usually points down, depending on whether you use European or American coordinate systems and the type of aircraft you're working on. But important for both Space Station and Dragon to be on the same coordinate system as they do this eventually as they step into the approach maneuvers here towards waypoint 2. Dragon will be using its relative navigation sensors, again, for relative position to the station, to make sure that it's on the approach, within the bounds of the approach corridor going towards the station when we get to that after this manual piloting test.
We should be getting to that shortly. This manual piloting test was slated to last about 25 minutes. And as we have been running ahead of schedule today, with all of Dragon's maneuvers, we could be looking at a docking only about 25 or 30 minutes from now. So once they're done with this manual flight test, they'll turn control back over to Dragon's flight computers, and they'll resume their approach, which had actually already started automatically before the crew issued a hold command to the vehicle. And then they'll press in to arrive at waypoint number 2, at which point the teams will do a final go, no-go for docking. They'll depart that 20-meter hold point, and it should be just about 5 minutes following that departure until we get contact and captured.
Yeah, and the crew right now are seated in Dragon in the pilot and commander's seat. Both of them are suited for what are relatively dynamic maneuvers. And they'll continue to be suited until we have confirmation of good hard capture on the space station. So right now, just interfacing with the touchscreen displays, testing out manual piloting. Hopefully secretly a little bit giddy to be piloting a spacecraft.
I mean, before they had launched, Bob Behnken had referred to this mission as every astronaut's dream, getting to launch in a new spacecraft, putting it through its paces. He and Doug Hurley, with those test pilot backgrounds, testing out a new spacecraft has to be as good as it gets. But they're still stepping through this manual piloting. We should have just a few more minutes until they're done with this Y-axis translation. And then they'll be able to turn command back over to Dragon, which will return itself to the docking axis and then begin that approach into waypoint 2.
Yeah, and as a look ahead, so when we do transition into that approach, Dragon will autonomously go towards waypoint 2, which is just 20 meters away from the forward international docking adapter on node 2. And it'll hold there. That'll give the ground team some time, both in Houston and here in Hawthorne, to do a go-no-go poll, make sure that the vehicle still looks healthy, make sure that everyone on board the space station and of course on board Dragon.
SpaceX Dragon, we've completed with the translation maneuvers. We're going to pick up with the closure maneuver.
We copy. We're following along with you.
All right, sounds like they're done with their translations. They're going to start moving it back to the docking axis, put us right back on the center line, and then we're going to resume that approach into station.
SpaceX, you have used 2/3 of your prop test budget.
I can copy 2/3 of the budget. Dragon. That completes the closure maneuver.
We copy. Closure maneuver complete.
That will move on to 4.041, section 4.
We copy and concur.
All right, so our manual flight test has been completed. We're standing by for them to now resume approach 1. So to move in from that waypoint 1, we're already inside of the keep out sphere at this point. Dragon's holding just 176 meters from the space station, and pretty soon they're going to be approaching.
SpaceX Dragon, that completes the manual piloting demonstration. I only had to twist Doug's arm for 2 or 3 minutes to get him to allow me to deactivate the piloting controls.
We copy. Excellent. Thank you. And with that, we ask that you, from the display used for manual piloting, please go to audio settings and adjust a gain setting for seat 1 or 4. And in addition, we would appreciate any handling qualities evaluation of the proximity piloting possible.
We've completed the gain setting adjustment for seat 1, and I'll turn it over to Doug for the handling qualities quick look.
SpaceX Dragon on the big loop for the handling qualities. It flew just about like the sim, so my congratulations to the folks in Hawthorne. Flew really well, very crisp. It was a little sloppier and wide, just like we saw in the sim, but all the other axes, as well as closure and opening, were all just as per.
Excellent to hear. Thank you.
That kind of gives you an indication of sort of how the design process works. You know, Bob and Doug have had lots of opportunities to test this out and sim it and give their feedback. And pretty cool to hear that their sim experience was very similar to what they saw actually on orbit. Just, I think you said 170 meters away from station right now?
Yeah, we're just 176, and I imagine as a spacecraft designer, that's exactly what you want to hear. Is the way that I trained you in it here on the ground is exactly how it performed once you're there for the real thing. So the second manual piloting test in the books, Bob and Doug putting Dragon through its paces. Now we're time to put it all to where we get to our endpoint. We're ready to get Dragon docked to the International Space Station.
Dragon SpaceX on big loop. The ground will be resuming approach shortly. We do plan to hold briefly at waypoint 2, so reminder that crew visors down are not required until the ground is preparing to command the final approach.
SpaceX Dragon, we copy. We'll hold at waypoint 2 for a pause, and then we'll get our visors then once you command.
We copy.
And station, it's Houston on the big loop. As you've heard, Endeavour is resuming its approach to waypoint 2. Chris, you can monitor now for step 2. That's step 2 and 1.104 Crew Dragon approach and retreat monitor.
Copy, step 2 will work.
Pretty cool view of the International Space Station from Dragon. This would actually be overlaid, or rather their controls would be overlaid on the displays on top of this view. And we got to see some pretty cool views from behind. Actually, there's a view right there. You can see the station on their displays. Visors up, Doug in the left seat, Bob in the right seat.
Yeah, so at this moment, Dragon is going to be resuming the approach. As we heard them informing the crew They're going to have that one final hold when they're just 20 meters away. That's going to be at waypoint 2. We're expecting it to be a brief hold while the teams all tag up and do a final go to move in for docking. Getting a great look at the space station itself. The docking port is right in the center of our screen. You can see another spacecraft currently docked to the space station, the Japanese HTV spacecraft currently docked to the Earth-facing port. One of those common berthing mechanisms also on Node 2. So Dragon will be the second vehicle to be docked to the Harmony module once it makes its final approach. And it's moving in right now. Again, just to give you an idea of how quickly they're moving, they're going at about 0.3 of a meter per second right now. And so if you're having any trouble with that docking simulator online, remember to just slow things down a little bit and your chances will go up exponentially. We just passed 140 meters away. We'll get our live video comm back with the space station momentarily. As soon as we do, we'll bring you back up there. But for now, Bob and Doug continuing to fly in. They're just 135 meters away.
Station on the big loop. In step 2, review of steps 3 and 4 is complete. Crew is on the International Space Station is ready for docking.
Station Houston on the big loop. We copied the review of 3 and 4 complete. International Space Station ready. Thank you.
Expedition 63 Commander Chris Cassidy giving the report. Station is ready for docking.
Yeah, and you can see the trajectory of the spacecraft. There are small corrections that are happening. So as we get closer and closer to station, we're trying to stay within those 2 corridors, which are shown coming out of the docking port that we're going towards. That little dot, I think, was the 20-meter hold point. So that's where we expect there to be the spacecraft holding right in front of the International Docking Adapter. There'll be a go, no-go poll. The ground teams have worked hard over the past probably years to come up with a set of what we call flight rules. So those are technical constraints, items that we look for, that if any of those criteria were violated, then we have a rule that we've predetermined, gives us guidance to say whether we could approach or not. So far, our vehicle has been very healthy, but technical ground teams will all do their due diligence to make sure that it's still safe to approach.
Right, and at this moment, that approach is continuing, still moving in at about 0.3 of a meter per second. Dragon's coming up on just 100 meters away from the space station.
So the very top there is the nose cone on the spacecraft, where we've got a cool view. Left side of your screen is the International Space Station. Right side of your screen is Dragon.
We're inside 100 meters, continuing to close. Again, we're going to have a short hold at 20 meters. Teams will just do a final check, and then they'll give Dragon the go. We're expecting it to be pretty brief. We should get to that hold point in just about 4 minutes, moving at our current pace.
I think you can see a meatball and American flag on that on the spacecraft. The NASA logo, of course, referred to as the meatball. I think there was some spirited discussion about the meatball versus the worm during ascent. And you can see those logos. That structure on the fairing structure is actually what the Super Dracos are housed in. Of course, all of those are deactivated now, only used for launch escape during the ascent portion. Nose cone right at the top of the vehicle. And you can see sort of the sealing surface, those four circular slots right underneath the nose cone within that red ring are the forward bulkhead Dracos. That's what we were using while we were conducting all those burns, the 5 burns to get to this point. Right now, we don't have a reason to use those. We'll only be making small attitude corrections with the service section Dracos. And you can see the service section actually pretty clearly here too. There's a black portion and a white portion sort of separated by a fin. The black portion is solar panels, solar cells that'll charge Dragon's batteries, and the bottom side are the white portion is actually a thermal radiator that's used to keep the spacecraft nice and cool. Of course, the avionics and the cabin, making sure that Bob and Doug are comfortable inside.
It looks like we're getting a shadow cast. We are just 60 meters away, continuing to close in, just about 40 meters to go until we're at that hold point. Should get there in just over 2 minutes. Meanwhile, teams in Hawthorne and in Houston doing their internal go, no go for docking. They're going to get all the teams polled. Once everyone's go, we'll be able to give Dragon the final go ahead for the vehicle to autonomously fly in and dock with the International Space Station. Should be coming up on waypoint 2 arrival in just about 1 minute, 45 seconds. At this point, it'll be 20 meters away from that docking port. The International Docking Adapter number 2 attached to pressurized mating adapter number 2 at the very forward end of the Harmony module.
Right there on the, right around the center, you can see the forward hatch. It's got a window in it. You can see a couple of handles, and there's some features that look sort of bronze-ish. Those are the pedals that we were talking about earlier as part of the soft capture system. So pretty wild, too, to see. We're so close that we're getting shadows from the station on Dragon. Wow.
And we're getting these views of Dragon's approach from 2 cameras that are right next to that docking adapter. And the movement's a little jarring at times. These cameras are being commanded by a person at the Cronus console in Mission Control Houston, and they send some very basic function commands to the camera, which it then executes automatically. And so they're continuing to follow Dragon in, so we do thank them for their diligence to give us these views of this historic moment as we are just less than 30 meters away from docking.
Right above the NASA meatball logo, you can see 3 of the service section Draco thrusters.
That's right, 12 in all. So the 4 of those clusters spread around the vehicle, used for a lot of the attitude control and any small translational maneuvers like we just watched Bob and Doug execute with their second manual flight test.
Yeah, and actually oriented in a way, too, where if you were to lose some of those thrusters, you still have redundancy and control in those axes. That's part of the reason why they're sort of at the angles that they are.
All right, so we should be getting to waypoint 2 right now. So it looks like we do have that hold.
Dragon SpaceX on Big Loop. The ground is go for approach 2. We will be enabling the resume shortly. As a reminder, ensure your visors are closed prior to Dragon's departure from the waypoint. And once Dragon is inside, the crew hands-off point, retreat and breakout are not permitted. And for your awareness, we have sunset in a little less than 8.5 minutes.
Dragon copies all on the Big Loop. Go for docking.
So Doug on the spacecraft confirming their go for docking. They're going to put down their visors. Got some instructions there about the crew hands-off point that we had talked about earlier. That's a point where we don't want the crew issuing any commands to the vehicle. It's about just about 2 meters away from the docking adapter. I believe the number is about 1.7 meters.
Station Houston on the Big Loop. Houston and station are now go for docking. Chris, you can monitor per steps 3 and 4. 3 and 4 in 1.104 Crew Dragon approach and retreat monitoring.
Copy steps 3 and 4. Next Dragon on the Big Loop. Our visors are down.
Copy, visors down.
With the crew confirming their visors down, we should see the final approach resume.
SpaceX Dragon on the big loop. We are inbound from approach 2.
Copy, inbound.
Station copy.
And we're going to be racing that sunset. The approach has resumed. Dragon closing in. We're inside 20 meters. And yeah, that crew hands-off point should come up in about 3 minutes or so. Right before we get that final docking, it comes about 20 seconds prior, or just about 2 meters away from the station still. And that's just the crew not issuing any abort commands. At that point, it would be too late. And so any aborts would be executed automatically by Dragon itself. So we're closing in at less than 1/10 of a meter per second at this point.
You can see the surface section Draco is just doing all these very small, minor attitude corrections. Really, the autonomous docking system at work, making sure that the vestibule and the soft capture system is lined up with IDA2. It's the International Docking Adapter. You can see much more clearly there the hinge mechanism for the nose cone. Those 4 black circles are the forward bulkhead Dracos, not to be used at this time. And then, of course, the pedals of the soft capture system. Wow.
Dragon on the big loop. We're inside 10 meters. We cannot make out the docking target, but we do see the outline.
We copy and concur, 10 meters.
Right, we're less than 10 meters away. Again, we're closing at that rate of less than 1/10 of a meter per second. We should be just about 1 minute 45 seconds away from docking.
There's a center line camera right in that middle, so that you can see where the forward hatch is, and right in the middle of that there's a window, and there's a center line camera that is aligned with the center of the vehicle and the center of the docking mechanism. So that is what the autonomous docking system is using to line up with sort of a cross hatch, cross target on the docking port. Again, the forward docking port on PMA2, or the pressurized mating adapter.
And we are just 5 meters away. Again, we're racing that sunset. This Dragon continues to close, 4 meters to go.
Those shadows of the space station on the vehicle. Yeah, you can actually see the centerline camera pretty clearly there. Sort of with the contrast of the sun right now.
3 meters to go. Two meters. We are inside the hands-off point, the chop, the crew hands-off point. 1 meter to go. Soft capture complete.
Dragon in space. Soft capture confirmed. Stand by for retraction and docking.
And we just heard it, soft capture. We have docking, that coming at 7:16 a.m. Pacific time, with the station and Dragon flying 262 statute miles right over the border between northern China and Mongolia.
You saw a little bit of motion there of Dragon. That was that relative motion that the soft capture system is damping out. Once that motion is clear, then the soft capture system will be retracted, and Dragon will go for hard capture.
Again, if just now tuning in, that soft capture, that docking coming 7:16 a.m. Pacific, 10:16 a.m. over on the East Coast. Dragon and the International Space Station were flying 262 statute miles right over the border between northern China and Mongolia. So that soft capture ring now going to retract. It's one more step on the way to docking complete.
Copy. Please take it on board.
Yeah, and so the next step here is once the soft capture ring is retracted, there are 12 latches that we refer to as hard capture latches. Those are what will really create that pressure-tight seal between the Dragon spacecraft and the International Space Station. So once soft capture is complete, and I believe we'll get that call from our core here, Anna, then we'll get confirmation of hard capture, and the crew, of course, aboard have this information on their displays, so they'll also see indication of hard capture complete. And once those two steps are done, then that's docking complete.
That's right, and we're expecting to hear some words from everybody. A pretty monumental moment. I mean, for Doug Hurley, he's returning to where he last docked almost 9 years ago on the very last space shuttle mission, now commanding the very first commercial spacecraft to deliver astronauts to the International Space Station.
That's got to be cool for them. They've mentioned quite a few times that they're best friends, our favorite dads in space, as we've been calling them. This has got to be really cool for them. It's got to be really cool for their families too, watching this.
It looks like we have another quick handover. We'll get that video back shortly. We're about 75% complete already with that retraction. Once that retraction is completed, we'll keep an eye out for the 12 ready-to-hook indicators. Once those are ready, those 12 hooks will begin to engage, and that'll securely attach Dragon to the International Space Station.
Yeah, so right now the vehicle confirming that the soft capture system is deployed correctly and is fully retracted. And then once the soft capture system is fully retracted, that'll set up the vehicle to put in the hard capture pins. There's 12 of those around the docking ring, and that's what creates that airtight seal between the Dragon spacecraft and the International Space Station. The volume between, which we refer to as the vestibule, is currently not pressurized. Of course, it was just exposed to the vacuum of space until literally minutes ago, about 4 minutes ago. So just waiting for the vehicle to get that.
Dragon SpaceX, ring retraction complete. Docking sequence is holding for MCS reconfiguration.
All right, so we see those ready-to-hook indicators are lighting up green. So we should be just about to step into those 12 hooks beginning to engage to get that secure mate between Dragon and the International Docking Adapter on the space station.
Wow, right now those two vehicles are flying together. They are attached to each other.
It's been just under 19 hours since we lifted off. We're actually at about 18 hours, 58 minutes, and 42 seconds. So we promised about a 19-hour ride up to station, and we made it just a few minutes before that. They were able to dock a few minutes ahead of schedule. We were tracking them to still take about another 10 minutes, but able to step through all of their burns about 16 minutes ahead of schedule and get us to where we are now. If you missed it just a few moments ago, that initial docking coming at 7:16 a.m. Pacific, 10:16 a.m. over on the east coast of the United States, and they were 262 statute miles flying together over the northern border of China and Mongolia. So really exciting. We're just waiting for this docking complete to be confirmed. We're expecting to hear some words, obviously, from the crew on board and all the excited teams down here. We're just waiting for this moment. And then it's time to start getting Dragon integrated into the station. There will be an umbilical that will get mated, and that'll allow Dragon to flow data and power into the station systems, and then it'll be over to the crew.
Endeavour and station at Houston on the big loop. MCS is configured. We're proceeding with hook driving.
All right, and they did a quick, so the motion control system onboard station now back under those control moment gyros, so handed over from the Russian thrusters, and Dragon now given the go to drive those hooks. We have to do that changeover of attitude control before we drive those hooks, as the Russian thrusters a little bit more dynamic in their control of attitude, and if you had a thruster firing while you were starting to drive those hooks, that could miss a line. So going over to the smoother control moment gyros on the US side, now controlling the attitude on board the station, and those hooks, those 12 hooks on Dragon, about to start driving.
Right now, Dragon and ISS attached, just flying off the east coast of China, just underneath Japan. Attached to each other, we recently passed over to the orbital night, so we're on the currently the dark side of the world. And actually, we're lucky enough to see soft capture happen just as we were crossing over the Terminator line.
And if you're wondering what you're looking at, this is one of the cameras on the very outboard part of the Japanese experiment module, looking back in towards the very front part of Node 2, where Dragon is currently docked. We are in an orbital nighttime, that's why everything is so dark, but you're looking at Dragon. It is horizontal to the ground, so the hatch part is right where that green light pretty much is. You can see the nose cone still illuminated above it, and it is currently attached to an international docking adapter on the International Space Station.
And inside that capsule are Bob Behnken and Doug Hurley, first astronauts to fly on a privately developed vehicle up to the International Space Station. Both test pilots got to do some fun tests today. Have a few more steps before they can actually get aboard and ingress to the International Space Station. And that's what we heard over the big loop, that transition, which allows us to then proceed with hard capture.
And we're seeing the first set of hooks, so the first 6 out of the 12 are now closed, 6 more to go.
Again, there are 12 of those along the ring. And that helps us ensure that we have an airtight seal. It is vacuum around them right now, so we want to make sure we're keeping all of that valuable life support in the vehicle. Now the combined ISS Dragon vehicle.
Meanwhile, inside the capsule, Bob and Doug also standing by for this hard capture to complete. And once we have that docking complete call, they'll be able to start stepping through a number of procedures to get them ready to move into the International Space Station. They'll get the go-ahead to doff or get out of their suits, and then they'll have some activities on the Dragon side to prepare for the hatch opening. Chris Cassidy will mainly be working on the station side to pressurize the vestibule. So as Shiv has talked about, the space between the Dragon capsule and the space station was exposed to vacuum, and even after this tight seal has occurred, we'll still be at vacuum inside. So we'll actually open up a valve to supply air from the station side into that space between the Dragon and station hatchways, and they'll get it up to the same ambient pressure that we'll have inside of Dragon and on the station itself. They'll wait for it to thermally balance out, make sure we don't have any temperature swings as we're bringing it up from vacuum, so probably from a very cold temperature up to about 72 degrees that they have in their cabin temperature on board the station, and then we'll get the hatches open.
Dragon SpaceX, hard capture complete. Stand by for docking completion.
Copy.
And now that hard capture is complete, so that's confirmation of those 12 latches to create that airtight seal. Now that's complete. The umbilicals from the station side will interface with the Dragon vehicle umbilicals, and that'll provide power and communications through space station directly to Dragon. Pretty much the whole way up, Dragon's been using a combination of batteries and its solar cells pointed at the sun to make sure that it has enough electrical power for the journey up.
And we're just standing by now for that umbilical to get mated, and that's going to, again, as Shiv was just saying, start the power and data transfer between Dragon and the space station. They've been transmitting data through RF radio frequency on the way uphill, and during the final approach, this will give a hard mate, basically a wired LAN connection between the Dragon spacecraft and the International Space Station itself, and then also being able to draw power from the station systems using those great big solar arrays that are used to generate all of the electricity for systems on board the station. And the soft capture system has been stowed. We see the umbilical starting to deploy. About 40% of the way so far, going pretty quickly. Should just take a couple more seconds until we're all the way connected. And then we should be getting that docking complete call out from the core here in Mission Control, SpaceX and Hawthorne. Standing by.
Dragon SpaceX, docking sequence is complete.
SpaceX Dragon, we copy docking complete. To say that it's been a real honor to be just a small part of this 9-year endeavor since the last time a United States spaceship has docked with the International Space Station. We have to congratulate the men and women of SpaceX at Hawthorne, McGregor, and at Kennedy Space Center. Their incredible efforts over the last several years to make this possible cannot go overstated. I'd also like to thank Kathy Leaders and her team of the Commercial Crew Program of NASA. An outstanding job by everyone. Last, I'd like to thank the men and women of the National Aeronautics and Space Agency. This is an incredible time to be at NASA. 3 new vehicles to be flown, continuing mission in low Earth orbit, and then to the moon and Mars. We thank you again and congratulate you.
Dragon arriving. Crew of Expedition 63 is honored to welcome Dragon and the Commercial Crew Program to welcome aboard the International Space Station. Bob and Doug, glad to have you as part of the crew. Well done. Bravo Zulu.
We're happy. Thank you, Chris. Thank you, Chris.
Endeavour, this is Houston. Bob and Doug, welcome to the International Space Station. after your spectacular rendezvous and docking of the first Crew Dragon vehicle. For the first time since the retirement of the space shuttle, you have completed a historic ride to the ISS and have opened up a new chapter in human space exploration. On behalf of the flight control teams here in Houston and in Hawthorne, California, and to our SpaceX colleagues, bravo on a magnificent moment in spaceflight history and on the start of a new journey that has changed the face of space travel in this new era of space transportation. Bob and Doug, good luck, and we look forward to working with you on board.
Dragon SpaceX, Bob and Doug, we here at SpaceX are honored to have been part of ushering in this new era of human spaceflight. On behalf of the SpaceX and NASA partnership, congratulations on a phenomenal accomplishment and welcome to the International Space Station.
Well, thank you, Anna. We appreciate all the good words and everyone thanking us, but it truly was a magnificent effort by the entire team, the SpaceX team, the NASA team, and a team across America who was able to pull this off and bring human spaceflight again to our nation. Thanks for everything. Happy to be aboard.
And Dragon SpaceX, with that, ground will be enabling hardline power and comm connection shortly. You are go to doff your suits per procedure 4.012. We will be configuring your video to go external shortly, and we have one request for Bob's suit doffing when you're ready to copy.
We copy all. Go ahead for Bob's suit.
During your approach suit leak check, we noticed Bob's suit pass with a lower PSID than his previous vehicle and O&C checks. We still had plenty of margin to support you in a depress, but in order to rule out potential hardware issues, when Bob is doffing, after he opens his structural zipper, check all 3 bladder zipper heads to see if any are partially closed. It is possible that if the head is backed off slightly, that the white tooth is partially visible or a small gap can be seen between the end of the zipper head and the gasket end. Please report observations.
Copy. Bob will take a close look at his zippers when he doffs, and he'll get doffing first, so we'll let you know as soon as we see something or if we see something.
Great. Thank you so much.
Wow. So now Dragon has completed its docking sequence. There's a number of checks. That was an absolutely historic moment. And in spite of that, the ground team's getting right back to business.